everyone. For the region bounded by the graphs of y equals log of x plus 1, y equals 1, and x equals 0, we're going to find the volume of the solid generated by revolving the region about the y-axis. All right, so first we're going to, since it's the volume of the solid of revolution about the y-axis, we're going to use this formula. So we need to solve for x here. And if we have y equals log of x plus 1, I can rewrite this as x plus 1 equals e to the power of y. And then solving for x, we'll get x equals e to the power of y minus 1. All right, so we solved for x here. We also have y equals 1, so let's find our intersection point by setting y equals y. So I put a 1 here for y. I get log of x plus 1, and log of x plus 1 is really just going to be blah, blah, blah. It's going to be, let's just write log of x plus 1. So that means I'm going to have x plus 1 equals e to the power of 1. Therefore, x equals e minus 1. All right. So if I graph this, let's see what we have. Now we know from your parent function that if you just graph log of x, that would be something like this, and it goes through like that. But since we have x plus 1, this is a horizontal to the shift to the left by 1. So I'm going to move this over by 1. I would have an asymptote here. So it's going to be, this is going to be our graph here. All right. I'm going to erase some of this green stuff here. All right. So that's what that graph is a sketch of. And then our intersection points are going to be at e minus 1 for your x, and then your y is 1. So let's go up here, and this would equal 1. So the shaded region that we want from 0 to 1, and we're revolving about the y-axis, is this area. All right. Now to set it up, we're going to use this formula now. So this is going to be volume equals pi times the integral, and we're going from 0 to 1 of x squared dy. All right, this equals pi times the integral of 0 to 1 of our x squared. So it's going to be e to the power of y minus 1 squared dy. Now in the next slide, I'm just going to expand this, and then we can integrate. So we're going to get pi times the integral of 0 to 1 e to the power of 2y minus 2e to the power of y plus 1 dy. All right, let's integrate this. We're going to get pi, and this is first one's going to be 1/2 e to the power of 2y minus 2e to the power of y plus y. And we're evaluating this from 0 to 1. This is going to give me pi, and then we're going to have 1/2 e squared minus 2e plus 1. And then minus, let's do the 0. So it's going to be 1/2 e to the power of 0 minus 2e to the power of 0. All right. Now, let's see what we get with this. E to the power of 0 is just 1. So we're going to end up getting pi times 1/2 e squared minus 2e, and then we're adding the 1 minus 1 minus 1/2 and then 2 negatives plus 1. So this is going to end up being plus 5/2. All right, and we can pull out a 2 here. If I pull out a 2, I can rewrite this as pi divided by 2, and we'd have e squared, but we have to multiply this by 2. So that would be 4e plus 5. So this is just a little nicer way to write it. This answer is fine as well. Thank you. Have a nice day. Bye-bye.